So you've probably seen the headlines, right? It feels like every other week someone is claiming we've finally done it, that we've achieved artificial general intelligence, or AGI. But what if that's not really the whole story? Today we're diving into a really compelling argument that what we're seeing isn't true flexible intelligence. It's something else entirely, a powerful and kind of deceptive statistical illusion.
This quote, it just gets right to the heart of it, doesn't it? It perfectly captures that tension between the AGI hype that we're all swimming in and the actual reality of what these amazing technologies can do right now. Let's start breaking down that gap.
And this is the core idea we're going to unpack today. We're going to explore that absolutely crucial difference between a system that can brilliantly mimic intelligent behavior using mind-boggling statistics and a system that actually possesses genuine, flexible, adaptable intelligence. They might look similar on the surface, but trust me, they are not the same thing.
Okay, so how did we even get to this point of confusion? Well, a huge part of the answer is that the very definition of AGI has, it's shifted. The goalposts have been moved, and that makes it seem like we're way closer to the target than we actually are.
This slide just lays it out so clearly. Look at the original idea of AGI. It was all about these deep cognitive abilities, being flexible, robust, able to adapt to something totally new. Now look at the redefined version. It's all about performance metrics, crushing benchmarks, getting a task done, being economically useful. It's a fundamentally different and, frankly, a much lower bar.
Let's really dig into that original vision for a second. The early pioneers, they weren't just thinking about a program that could ace a test. No way. They imagined a system that could be competent in pretty much any environment. One that could learn and solve problems it had never, ever seen before. Not just one that's great at recognizing patterns from the data we fed it.
This quote just nails the fundamental mistake we're making. We're confusing a very, very sophisticated imitation with the real deal. It's an incredible approximation for sure, but at the end of the day, it's still just that, an approximation.
Okay, so let's dive into the next piece of this puzzle, our complete reliance on benchmarks. We see these amazing test scores and we automatically assume it means intelligence, but that's a real trap.
You see a number like this, right? A headline grabbing 98% on some major AI benchmarks, and it just feels like proof. It feels like, wow, we're there. This is exactly the kind of data point that fuels all that AGI hype. But what does a score like this actually tell us?
Well, the thing is, benchmarks have some really serious flaws. They test for super narrow skills in a total vacuum, completely separated from the messiness and context of the real world. And, maybe most importantly, they can be gamed. You can totally teach to the test, optimizing an AI to get a high score without it gaining 1 ounce of real understanding.
The Turing test is a perfect example of this. You might remember a chatbot called Eugene Goostman that famously passed it a few years back. But how did it do it? Not with real intelligence. It did it with clever conversational tricks and by exploiting human gullibility. It pretended to be a 13-year-old boy so its mistakes would be forgiven. It was a performance, a clever hack, not a breakthrough in consciousness.
And here's the ultimate reality check for you, the economy. If we really had AGI, we'd be seeing massive economic disruption, huge productivity booms all over the place. But the actual data? It shows the complete opposite. The hype promises this incredible level of automation, but in reality, only a tiny, tiny fraction of jobs are fully automated, and the forecasts for productivity gains are surprisingly small.
This all leads us to a really core concept from cognitive psychology that helps explain this whole disconnect. Here it is. Just because an AI gives you the right output, it doesn't mean it went through the right process to get there.
Just think about that for a second. Can you get the correct answer, but for all the wrong reasons? It turns out the answer is a huge, resounding yes.
So there's this classic, almost unbelievable experiment with pigeons that illustrates this perfectly. Scientists actually trained pigeons to peck at photos that had people in them, and they got incredibly good at it, even with brand new photos. But nobody would claim the pigeons understood the abstract concept of a person. They were just pattern recognition masters. And in a way, large language models are doing something very similar. They are absolute masters at generating plausible-sounding text, but that doesn't mean they understand the concepts behind those words. And this isn't just some theory. When researchers actually compared how humans and LLMs evaluate things like news sources, the difference was just stark. When we humans face uncertainty, we pull back. We downgrade our confidence, we think about the stakes, the cost of being wrong. But LLMs? They often just double down. They'll issue these confident classifications simply because the text seems plausible, even if there's conflicting evidence.
Okay, so let's bring all this home. Why does this distinction, this difference between mimicking intelligence and truly having it, why does it matter so much?
It matters because when you measure them against those original, much more demanding standards for AGI, today's systems are still very, very limited. They're brittle. A tiny change in a prompt can give you a wildly different answer. They don't have their own goals, and they are completely dependent on us, humans, to set up their tasks and to fix their mistakes.
And that is why this is not just some nerdy academic debate. The source material for this explainer argues that confusing these two things, this approximation and real intelligence, is a massive strategic misjudgment, and it has serious real-world consequences.
It's like a chain of events. First, we overestimate what the AI can do. We start to believe it actually understands. Then, the next logical step is we give it trust and responsibility that it absolutely should not have, letting it make critical decisions. And finally, we end up embedding these brittle, flawed systems right into the foundations of our scientific and social institutions. That's a huge risk. So that really brings us to the central question we have to ask ourselves. The AI systems we have today are incredibly powerful, there's no doubt about it. They are amazing tools, but understanding their limits is every bit as important as celebrating their capabilities. Because the biggest risk here might not be the technology itself, but our own misunderstanding of what it is, and more importantly, what it isn't.